Hey everybody, teardown time again. I just bought these two thingamajigs off eBay. I actually bought one first, which was this one. Opened the lid to have a quick look, and I was quite impressed and went, right, I'm going to go and buy the other one as well. So I've just picked up a second one of these. This one isn't working, unfortunately. But this one does appear to be, to a certain extent anyway. So what we've got here is two Magstim 200s. They're made by the Magstim company. They're British made. Now what these are is a magnetic stimulation device. They're sort of the base unit to a magnetic stimulation. Now the main use for something like this is medical. It is often used to stimulate the brain, which is known as TMS, which is Transcranial Magnetic Stimulation. It's the most fantastic name. I love that. And it's a non-invasive way to induce an electrical current in your brain using a magnetic field. Now, interestingly, Ben Krasnow of Applied Science has actually played around with TMS on his channel. He made a couple of videos where he sort of built himself his own capacitor bank and discharge circuit to actually try and do it himself, and he actually had fairly good success, to be honest. So there'll be a link in the description, or even here somewhere in the video, so you can click and go through and see his videos that he did. Obviously these are commercial medical grade units, so I thought it'd be interesting to open one of these up, have a look around, and see if we can figure out anything. So in a little bit more detail, what you'd have with one of these that will plug into these ports here is a big long cable with a handheld device with a big coil at the end of it, which you would place on the side of your head, and then discharge a large capacitor into the coil, which induces the current inside your brain. So obviously these are going to be high voltage devices, high current. So it should make some interesting video on the inside. Now, as I said, obviously you can see I've got two of these. This one here does turn on, as you can see. Obviously I don't have the probe or coil or anything else to plug into this, so this has got so many safety interlocks. It basically I can move this around up to this will be the amount of charge. I can do that, but nothing else does anything. So I can't really do anything at all. So that's really all that does. The bottom one doesn't work. I've not even tried plugging it in, to be honest, because when I picked it up, it rattled, and there was a few components fell out the fan, which is around the back. So it's probably best not to plug that one in. So what I'm going to do is leave this one intact and take apart the one that's busted, broken, whatever, because I'm hoping that as I pull this one apart, I might be able to figure out a bit more how it works and maybe make use of this to some degree anyway. Right, so if we have a closer look at this, we have the output port, which is a fairly large multi-pole connector. We've got the wheel that we saw earlier. We've got bar graph display saying max and min. That I can't get that to change anything. We've got the output that you saw, a trigger button, run button and stop, and the main power switch. The actual case is of really substantial plastic. It's very solid, and the whole unit weight is incredibly heavy. I mean, it's probably getting on for about 17 kilos for the base unit here. So round the back we have a cooling fan. It's obviously seen a bit of damage there. We've got the mains input. We've got a trigger output and a trigger input. We've got a what looks like an RS232 port or something. We've got some jumper switches here, which refer to this chart here. So we've got switch 1, that's input, so we've got input and output. So these are the sort of rising and falling edges that you can use to trigger it, and I would imagine is what the actual output does as well. So when this is triggered, it'll output a positive going pulse or a negative, and you've got a switch for the duration as well. Now this here is some kind of BNC that looks like it's been tacked on afterwards, to be honest. Not sure what that's for. Right, I've actually already removed the screws to take the lid off this, because there's some really wacky security bits that I had to sort of hack out with a pair of pliers and a pair of snips. Managed to get them out in the end. So I'll just turn this back around and we can have a look on the inside. Okay, I'll just take the lid off here. Right, so obviously we can see the rather large dominating capacitor that's in here. It is absolutely enormous. We've also got here some wire wound resistors. We've got some potted devices here. We've got a HV transformer, which is rated at 120 volt, 120 volt white primaries, and 0 to 3400 volts output. We've got the mains input coming in down there. I should point out that just off camera, I have just checked the voltage across this capacitor, and there is absolutely nothing on it. It's absolutely discharged, and it's actually connected to its bleed resistors as well. So this is absolutely safe at the moment, in case you're wondering. Got what looks to be a power supply board here, and we've got a board which runs down the front panel here, which is obviously the control electronics. Over here we've got some large terminals. Obviously this is going to be dealing with a fair amount of current. From the documents I've read, typically looking at about 5,000 amps, which is obviously not an insignificant amount, so obviously they're going to be fairly beefy. Now, as I mentioned previously, I have been inside the my other one of these, the one that does seem to turn on and seems to function. I've done a little bit of investigation about what is actually going on here. It's actually, although the principle of the system is actually pretty simple, it's obviously a whole lot more complicated when it comes to doing things in reality. So, and of course there's a whole lot of stuff in here for interlocks and safety and stuff like that. So it sort of grows in complexity. So where you'd sort of expect just a big capacitor, a charging transformer and an output switch, it's obviously a lot more complicated than that. So I'm just going to go around and tell you what I know and what I'm speculating, and then I'll start taking things apart and actually sort of have a look at this properly. First thing that I'm going to do is take out the capacitor. Because it actually comes out relatively easy, and it'll give me a bit more room in here as well to hopefully figure some of this stuff out. And it's also probably a good idea to have it not around. So if I show you down in here, we have the connections to the capacitor. So these just bolt up to this terminal here, and this terminal just here. So I just need to whiz those two bolts out, and then I can take the capacitor out. Right, I've just released those two nuts off, so I should be able to just lift this out. what I've done just there, I've just connected the capacitor terminals together, just so it can't build up any charge. So obviously you can see that the capacitor in here is rather large. There's also no markings on it, which I found quite unusual. It's pretty heavy, feels very dense. It's probably, I don't know, oil filled or something. It's probably where it's filled and evacuated. So it weighs about 4.7 kilos, which is pretty substantial. There's no rating on it at all. There looks to be, if I get this right in the light, there seems to be the remains of a sticker on here. So it looks like it, when they manufacture this, they peel off the manufacturer's label and just leave it unmarked, which is rather annoying, because I have no idea what this capacitor actually is rated to in terms of voltage. Obviously the capacity I can probably measure and work out, but the voltage, well, obviously it's a high voltage capacitor, but I don't know whether it's 1,000 volts or 5,000, so, or maybe even more, I don't know. There's a serial number and a date on there, 12th of the 12th 1994. Okay, the principles of operation of something like this is quite simple. You basically charge a big capacitor up to a high voltage and discharge that capacitor through a coil, and the coil generates a magnetic field, which then induces small currents into surrounding tissue and stuff around the coil. I believe for this type of device, they are looking at around up to about 3 Tesla, which is pretty high, but obviously it's concentrated in quite a small area. Switching currents apparently are about up to 5,000 amps. So if we think a little bit about the theory and how that applies to this, so we've got the output port right at the front here. That is connected to the coil, so you're going to need some device to switch the capacitor into the coil. You can't just have it connected all the time, obviously. So we've got a big device just down here. So this is the device that actually switches the capacitor to the front panel and ultimately the coil. We have, from the main connector down in here, we have these wires coming up here connecting to this terminal, and these ones here, which then connected to the actual capacitor. So these will be the negative side of the capacitor, because obviously you don't want any voltages on here. So the positive will be the switch side. So the capacitor connected to, as I said, this terminal here and this one here. So this device will just connect these together, and then that will discharge the capacitor into the coil. So I would imagine that's probably some kind of SCR or something. Now a bit further back, we have tucked away down here a large three pin device. It's probably easier to look at that once I've started taking some of this wiring off. And right at the back, in front of the fan, we have 4 PCBs. Top one's obviously got some power resistors on. And a bit further along, we have 2 what look like potted devices here. And then at the back, we have the transformer. And so that before that's a high voltage, seems to be a high voltage rated transformer. We've got some wiring blocks and connections down there, and I think this is a small power supply board, I think probably to run the logic side of it. So what I'm going to do now, I'm just going to chop all these cable ties so I can start pulling the wires out and just trying to sort of see exactly where the wires go and what the different parts might be doing, because I have no idea what these potted devices are. Right, well that's looks a bit more messy, but at least now I can actually trace wires to see where they go. Now the mains input to the transformer. This is the mains coming from the terminal block and the power switch that comes into this connector here on this module here. And then comes out and then goes into the transformer. So it looks like this is switching the transformer. I've got 3 wires there coming back over to the front control panel. We've got 1 wire which loops onto this control board, and that comes down to the positive terminal of the capacitor. There we go, should be able to see a bit better now. So this connector here, we've got 2 wires, one connects through to this module and the other one connects to there. Let's just come out. Not quite sure where that one goes yet. But the bottom one, that goes to the positive terminal down here that the capacitor was connected to. And I'm just going to take out this module here just so a large black box. It's definitely steel surrounding it. Looks like it's well potted in there. So we have the output from the transformer, which doesn't look like high voltage cable at all. That comes from the transformer. Oh, there's a splice here. Hang on. Oh, it comes out one cable comes out of the transformer, goes into this heat shrink, which just runs through one of the bolt holes on the transformer. So it runs through, out, down onto this board down at the bottom here, and then back up, back through there, and then out, and then into this. So this is in series with the transformer on this board here. I'm just going to remove these boards here so I can see what they're doing, because I can't really see the bottom one. Okay, so these 2 cables here, one's connected to the negative side of the capacitor and that one's connected to the positive. got 1, 2, 3, 4, so that's 8, 1.5K resistors. Got a 4 kV capacitor just there. I've got what looks like a relay here, which is a kilovac K81B235, 1270 ohm, 12 volt DC. Yeah, that looks like a relay, possibly a high voltage one. The board is labelled Novometrics. Now that name did come up when I was reading up about Magstim and the whole TMS procedure. I think Novometrics turned into Magstim after they developed this. I've just looked up this this relay. It is a high voltage relay. It's rated to 10 kV, 10,000 volts at 5 amps. So that's rather a substantial relay. Still a current product. $372 each. Wow, it's not cheap then. Right, if we go a bit deeper in here, we've got PCB with a very, very long trace on it. So there's some discoloration on there. I wonder whether it's been getting warm. So this is connected to this device down here, which you probably can't see yet, which is a 3-pin device, but there's only 2 connections on it, and they are, so one of these cables are connected across onto there, and then the other one, oh sorry, no, the negative terminal of the battery of the capacitor. So we've got traces on both sides. I wonder whether there's some kind of inductive device. And it looks like we've got another one underneath. Okay, this again, it's exactly the same board, but we have a device just there, temperature sensor, I guess. It's obviously been getting quite hot. And the board at the bottom here is in pretty bad shape. So this is obviously part of the. I actually don't want to disconnect these because it might help me figure out where everything, how it's all working. We got the. So these are in series with the transformer, so obviously something to do with the charging. Maybe it's the current limiting for the charging. Obviously you can see there something's gone rather disastrously wrong. Let's let out the magic smoke. Rather spectacularly. Right. Now I would like to find out what this 3-pin device is down here. It's rather large, potted, and it's covered in oops. There we go. It's a diode. 2 diodes. Half a bridge rectifier. So we've got an IXYS, MDD 95-16N1B. Yeah, it's a it's just called a standard rectifier module, 2 times 1600 volts, rated at 120 amps. Max blocking voltage 1600. So this will be a just a blocking diode. Obviously, when the capacitor discharges into the coil and it generates a huge magnetic field. When that field collapses, there's going to be all sorts of stuff coming back. So I suspect that's just a blocking diode to stop anything coming back. Right, so if we just go back to trying to figure out what's doing what. This potted box looks like it's charging, and yeah, they're basically the part of the charging circuit for the capacitor. Obviously this run through onto that board that's gone and released the magic smoke. So given that this has got the transformer switching, we've got some low voltage lines here which come back to the control panel here. So maybe these control switching onto this. Now this is actually in series with the transformer, so if that really is outputting 3400 volts, then maybe this is a rectifier. Maybe this is potted rectification. This box here is connected through to front panel again. And this is connected through to the actual main switch, which connects the capacitor to the coil. So this looks like some part of the triggering, I think. Now going back to this top board, given that this one seems to be, we've got 3 wires connecting in there, obviously they're going to be switching the relay. They come back and connect to the front logic board here, and they just seem to be connected across the capacitor terminal. So I think this is the discharge resistors. So these are the ones that bleed the capacitor down when it's turned off. Okay, I'm just going to take out the main, what is clearly the main switch. So it's connected to these 2 little bus bars. Looks like 2 SCRs. That's IRKT230-16. Okay, I've just got the data sheet for this. The IRK230-16 is 1600 volts, and maximum peak surge current is 7500 amps, and average on state is 230. 230 amps. Yeah, 230 amps continuous, and up to 7,500 peak. Now, interestingly, we're actually only using these two terminals. This one is covered in heat shrink. Okay, though, these are actually starting to answer some of the questions, because the voltage rating of these, that was 1200 for this one, and this one's, what did I say, 1700? 1600, sorry. So this one is 1600 volt, that is 1200. So I think the rating of this big capacitor is probably going to be in the order of 1000, thereabouts, because it certainly wouldn't be operating at more than what these are going to be rated to. Well, one thing I've just noticed is the Footswitch port at the back is air operated. This is just a plastic tube here which runs through to this this micro switch just here. So obviously, for safety reasons, you know, the voltages and everything that you have in here, it's operated by air, pneumatic, I should say. Right, I think what I'll do now is strip out the PCB that's on the that's attached to the front panel, and we'll have a quick look at that. Okay, it's labelled Novometrics, so we can find some dates. This one here is for anti-Z, ZN433CJ-10, dated 1985. These 1981, 1985, 1987, 1987. Yeah, so this is mid-80s, this one. The other one that I've got, which does power on, that one is dated from the late 90s. I think it was actually 1999. So they were obviously making this for a very, very long time. This one's got quite a number of little bodge boards attached to it. Oh, we've got a little counter. Presume that's the number of activations, the number of pulses it's done, which is 47,516. So obviously with all these little bodge boards and everything on here, we've got 1, 2, 3, 4. These have all been pushed into the normal IC sockets. So it's obviously small little bodges made to this. This is sort of looking at as though it's sort of late 80s, I would have thought. Now I believe this was born out of research that was conducted at Sheffield University in 1985 on Novometrics, and Magstim were part of that team, or the team set up the company Magstim. So this is all based on university research. We've got some optical things. Oh, I see. Oh, that's clever. The rotary dial on the front here, you can just see it here in the corner. It's just a freewheeling wheel and there's 3 sensors just here. Yeah. So the wheel is encoded. with the patterns there onto optical sensors. That's quite a neat solution, that. On the front here we've got lots of LED modules for the bar graphs and status lights, etc. This device here, that's a AD converter. We've got HEF 4059BP, which is a programmable divide counter. It's all pretty simple stuff on here, isn't it? We've got an EPROM just there, so I will pull that out and we'll have a look at that later. We've got the wiring that runs out to the front port, so we've got the high current cable, so we've got 4 of those, and a load of smaller ones which plugged into the main circuit board. Right, so really the last things to look at are this transformer. The label on the top says 120 plus 120, 0 to 3400 volts, so I'm not quite sure why that is the case, given that the capacitor and the switching seem to be a lot lower voltage than that. There's not a whole lot happening down here, to be honest. It's all just wiring connections, mains coming in. We've got this power supply board here. Yeah, this just looks like the power supply for the logic board. Doesn't say what voltage it is. Probably 5 and 12 volts, I would have thought. Yeah. ID label on the transformer, HV transformer KL8098 120 plus 120 slash 0 to 3400V, Kindrace Limited transformers, serial number 3. So he didn't make many of those. Right, so all we've really got in the bottom here now is there's a big ferrite just there, the IEC connector, board at the back. Right, I think that's pretty much it. Right, I think that pretty much concludes taking this apart. It's been a bit protracted, this one, but because there's when you have mystery boxes like this where you just don't really know what they're doing, then, and I couldn't even though I've got a working one down here, I can't get it to actually power on and start charging the capacitor up or do anything like that, because there's just too many interlocks in it, and it just will not do it. So it's hard to figure out what these things do when nothing actually works. So I think I will probably do a little bit more investigation off camera, and then maybe do a short follow-up video or something. Right, thanks for watching, everybody. I hope you found it interesting. I'll see you on the next video. See you soon.